Welcome to the lecture. You may recall that in the earlier lecture we had considered an example in which we had considered some data set and we had exposed it to a statistical software, and after that we had analyzed the statistical outcome. We had learned how to interpret the different components of a statistical outcome, and based on that how we are going to conclude about the statistical model. In that example, you may recall that everything was nice. Means as soon as we hit the model, means everything was coming out exactly in the same way as we had studied in the lecture. In practice, this is always not possible. A good statistical model is not usually obtainable in a first attempt. Rather, it's a sort of iterative process. We start with the data, we try to investigate it from different perspectives, and then we try to get a model. By looking at the outcome of the statistical software, we try to decide whether the model which we are going to obtain is good or bad. Does this satisfy all the assumptions of the linear regression model? Is there any problem in the outcome? And based on that, we try to diagnose all the problems in the model. Then in the second step, we try to correct it, and then we reconduct the statistical analysis once again. And this process continues till we obtain a good statistical model. So, in order to illustrate these type of aspects, I have considered a data set of size 100. Right, size 100 I am taking because that's a little bit large data set. Earlier we had taken a very small data set in which you can see everything from the eyes very easily. So, now we are going to consider some other complexities which are involved in the data set. So, now let us try to come on this example, and if you try to see here, I already have entered this data in the MINITAB software. Right. So, I am considering here 6 independent variables, and its outcome is given here in the first column as y. Right. So, now first of all we have to investigate that whether a linear regression model can be fitted over here or not. So, you may see that in the earlier case we had only 3 variables, so I can make different types of things, but here now we have here 6 variables, so things are not so straightforward, but still we make an attempt. Right. So, we try to make here a matrix scatter plot, and means I will try to choose here all the variables. Right. And if you try to see this this matrix scatter plot comes out to be quite clumsy, but still you can see here that it is trying to give us some information, but it is pretty difficult here. So, what I try to do here, I try to make or consider 2 variables at a time. So, I try to make here a scatter plot once again, and I try to consider say only x1 and x2. Right, and one can obtain a scatter plot like this. And similarly, I try to consider 2 variables at a time. Right, now I try to consider here y and x3 and x4. Right, and we get here a plot like this one. And similarly, I try to make here another graph with the variables x5 and x6. Y versus x5 and x6. Yeah, and I try to bring these graphs in a separate sheet so that we can discuss it later on. Right. Okay. After this, we try to fit here a model, and we try to give the continuous predictor here as say x1, x2, x3, x4, x5, x6. Right. Okay. And now we have to give here different types of options. So, for example, here I am including the intercept term in the model. Okay. and we are going for different types of options. That here I am going to consider the level of significance to be 5%. So, the confidence level for all the interval is at 95% over here, and we are going to consider the two-sided test of hypothesis, and we are going to consider the adjusted or simple sum of squares. Okay. Now, we would like to have different types of graph. We can have the histogram of residuals, normal probability plus residuals versus fit, and here you would try to see that I am also considering here the histogram of residuals. This graphic will make here sense because we have 100 observation. In the earlier case we had just 30 observations, so it does not make much sense, or it does not give good information to us. And for the result, I will try to have all the things: method, analysis of variance, model summary, coefficient, regression equation, fits and diagnostic. And this I am now doing only for unusual observation, because there are 100 observation, otherwise we will get a very long table. So, we are interested only in the unusual observation, and we would like to have here the Durbin-Watson test statistic. Okay. And now, let us try to obtain the result. So, you can see here that this is the histogram that we are obtaining here, and this is a sort of residual versus fit that is obtained over here. And similarly here we obtain some other graphics like as here. This is the residual versus fitted value, and similarly we have obtained here the normal probability plot. Right. Now, if you try to look at the outcome, so we have obtained here the analysis of variance table, and here we have obtained the model summary, then we have obtained here the coefficients, finally we have the regression equation here, and similarly these are some statistics for the unusual observations, right, and then finally we have Durbin-Watson test statistic. So, I just copy all the things in a separate sheet, and then we try to understand the entire analysis. Right. Okay. So, now you can see here that we are considering here a linear regression model with 6 explanatory variables, which are denoted by here x1, x2, x3, x4, x5 and s6, and based on that we have written this model. And we are considering here 100 observations, so n is equal to 100, and the number of independent variables including the intercept term, that is now here k, it is 7, right. Okay. So, now this is the matrix scatter plot that we had obtained earlier. You can see that here it is quite clumsy, and it is difficult to get a very clear information, although you can see here that this is giving a plot between y and x1, this is between y and x2, this is between y and x3, this is between y and x4, this is between y and x5, and this is between y and x6. And these are the plots. For example, this is the plot between x1 and x2 and so on, right. And we also have to take care of the scale also, so that we can find out whether there is really a linear pattern or not. So, now you can see the first complexity when you are dealing with the higher number of independent variables and a large number of data set. So, we try to use here one thing, that we try to consider this matrix plot with 2 variables at a time. So, I try to plot here y with respect to x1 and x2, and we plot this diagram, and yeah, that looks quite say this informative as compared to earlier, but you can see here the range here is between 0 to 1600, right. So, that is why this is not giving us a very clear inference, but still we can see here that is not actually 100% random. There seems to be some trend over here. And when we are trying to look at this one, this is clearly giving us a linear trend. So, there is no issue. And when we are trying to look at the scatter diagram between x1 and x2, they are also here the range is not actually much between 0 and 4 there, and that is clearly indicating that x1 and x2 are independent. Similarly, when we try to look at the next matrix plot, which is between y, x3 and x4, we have a similar thing. Again, the range here is very, very high in this case, and in this case also the range is very, very high. This is here is 0 to 1600. But still we can see that there seem to be some approximate linear trend over here at the good important and an important part is that here the range is not that high, it is between only 2 and 6, and this scatter diagram is indicating that x3 and x4 are also independent. And similarly, if we try to consider the matrix scatter plot of x5 and s6, that is again similar to other plots. So here you can see, although we are considering two variables at a time, but still that is not giving us a very clear picture that what is really happening. We are not 100% convinced. So what we try to do here, that we had plotted the surface plots. Right, the surface plots we had considered in the earlier lecture that they can be obtained in the software MINITAB just by a click, and in other softwares also they can be obtained very easily. One can see here that there is a linear trend which is going like this here, you can see. So one can see that and the different shades here, for example, here you can see the shade is quite dark, whereas you can see here the shade here is quite light. So they are going to give us the folds of the surfaces. For example, here you can see that there is a dip, and here also there is a sort of here up, right. So but still more or less it is showing that the relationship of y with respect to x1 and x2 jointly is not that bad. And similarly, when I try to plot here y with respect to x3 and x4, so you can see here there are some sharp peaks over here, just like small mountains, right. And this type of perturbation, they are trying to give us an idea about the disturbances on the surface. But still one can see here that there is a sort of linear trend over here. Right. So yeah, we can be confident that there is a sort of joint relationship between x1 and x2 with respect to y is not bad, and it is approximately linear. And similarly, when we try to plot y with respect to x5 and x6, we can see that here these perturbations are a little bit higher, and the peaks and the depth of the surfaces, like as here the peak and here the depth, and here the depth, for example, here the peak, they are pretty high, and they are higher than the such deviations in comparison to x1, x2 and x3 and x4. And here also we can see here that there is a sort of increasing linear trend, right. But still you have to keep in mind that these are the relationship of two independent variable with respect to response variable, and there are three possible outcomes. So, and similarly we have to make such figures with respect to all possible combination, like as x1, x3, x4, x1, x4, x1, x5, and then based on that you have to take a final decision by combining all the outcomes together. That whether the relationship is going to be linear or not. So I had plotted all the things. I am skipping all those figures, but I have taken these three figures to illustrate the methodology. But finally, I can conclude, yes, I can fit here a linear regression model. And also remember one thing, these are the individual relationship of two variables with response variable at a time. But we are actually interested in the joint relationship of 6 explanatory variables with respect to y. So when we find that the pairwise relationship of independent variables with respect to the response variables are quite linear, then we can expect that their linear combination will also be linear. So this is how we try to take a final judgment, because final judgment has to be in terms of yes or no, whether I can fit a linear regression model or not. Now first I try to consider the outcome of a software in the form of regression coefficients. I'm not going to discuss here now all the components because we had discussed it in the earlier lecture, and this is the similar software outcome. So these are here the regression coefficients that are obtained, and these are here their respective confidence interval. And so first we try to look at here look at the p values, right? And we can see here that we had considered the alpha to be 0.05. So now there are three values, one is here intercept term and two values here corresponding to x4 and x5, which are higher than 0.05. So we can conclude that when we are trying to test the hypothesis H naught beta 4 equal to 0 and H naught beta 5 equal to 0, both are going to be accepted. Right. So we can conclude here now that x4 and x5 are not much important, in the sense that they are not contributing significantly in explaining the variation in y. And we have obtained this model over here, right. One thing you have to notice here that there are some terms which have got a positive sign and there are some terms which have got here a negative sign. So we have understood that the meaning of the plus sign is that the relationship between say here y and x1 is increasing. So y is increasing as x1 increases, but similarly for the x3 here the sign here is negative. So that means the relationship between y and x3 is decreasing. So as x3 increases, the outcome of y decreases. Right. Now when we look at the model summary, we can see that the R square is coming out to be pretty high, right, and even the R square prediction is also pretty high. So the fitted model is good, but now there is a doubt that x4 and x5 variables are not contributing much, and similarly is the doubt for the presence of here intercept term also here, right. So we try to now consider the analysis of variance part. So here we are essentially interested in testing the hypothesis H naught beta 1 equal to beta 2 up to here beta 6 is equal to 0. So you can see here that the corresponding p value is coming out to be close to 0. So one can conclude that at 5% level of significance that none of the individual variable is close to 0. But again you can see now this is contradicting between the outcome that we had obtained earlier, that x4 and x5 are not contributing much. So now we try to understand that how to conclude finally. Right. So next we considered different types of fits and the diagnostic, and they have been obtained only for the unusual observations. So you can see here that the software is diagnosing that these many observations, they are looking to be unusual, and they have obtained different types of residuals, standardized residual, deleted residuals, and this is the value of here HII, means the ith diagonal value of the hat matrix H, and Cook's distance over here, and d-fit statistics. So this we already have understood in the earlier lecture, that how to interpret these things, but based on that now we have an idea that observations number here 2, 3, 47 and 66 and 87 and 90, they are the large residual which are denoted by here R, and observation number here 79, this is some unusual observation. So now this is our responsibility to go back into the data and we look into the behavior of this observation, and then we have to take a final call whether they are really influential observation, outliers, or they are unusual observation, or say leverage point. And one can also see here that the Durbin-Watson statistics is coming out to be here 1.60, and this indicates that the rule of Durbin-Watson statistic that we had discussed earlier, that if d is smaller than 2, then this indicates the presence of positive autocorrelation. So one thing we have diagnosed here, that there is a possibility of presence of first order positive autocorrelation, and that is possibly making these types of strange observations in the earlier analysis. So now what we do here, that since we have now obtained that the two variables x4 and x5 are not good, so our next objective will be that to conduct the analysis once again by removing these variables. But before that, let us try to look at the different graphical outcomes of the same analysis. So here I have plotted the histogram of ordinary residuals and standardized residual. So these residuals also have a normal distribution, but since you can see here that since we have only here 100 observation, so one can fit here a curve like this one, but still that is not 100% normal. But that we know that in case if we try to have more observation, possibly this picture may tends towards normal curvature. And similarly here also the picture looks like this. So it is not 100% normal, but it is giving us a good confidence that if we have some more number of observation, possibly this picture will look more normal. A more stronger conclusion can be obtained from the normal probability plot, and this normal probability plot is plotted here for the ordinary residuals and for the standardized residuals. And one can see here that all the points are lying here mostly around the straight line, right. So one can conclude here that the observations are coming from a normal population. Next we have made the plots of residuals versus fit and their standardized residuals versus fit. And one can see here that most of the observation they are enclosed in a sort of this horizontal band, right. So one can say that here that there is not much issue and the variance remains almost the constant, right. So now we have seen here that the two independent variable x4 and x5, they are turning out to be not contributing towards the model. So we try to conduct this regression analysis once again by ignoring the two variables. So we try to do it here again, and we consider a linear regression of y with respect to 4 variables only, x1, x2, x3 and x6, right. And we try to obtain here the similar thing. You can see here we have obtained here the histogram of residuals, the plot of residuals versus fit, and the normal probability plot over here, and whatever are the observations that we have obtained here, the statistical outcome, this I am trying to copy and bring it to another sheet so that we can discuss about them. Okay. So you can see here this is the same outcome that we had obtained earlier. So now you can see here that we are only considering here x1, x2, x3 and x6. And now if you see here, now the resulting p values here, they are given in this column, and you can see that they are somehow a little bit changed than earlier. But still this constant term is still indicating that the presence of a constant term is possibly not desirable. So that we have to explore further. But again that depends on the situation and the experimental conditions. If you remember, the interpretation of the intercept term was that it is the value of average value of y when all the independent variables takes value 0. So the experimenter has to take a final call that whether there has to be an intercept term or not. But anyway, we have reconducted the analysis, and finally we have obtained this model, and you can see that this model and the values of regression coefficients, they are pretty different than what we had obtained earlier. And this variance inflation factor also, they are very close to here 1. So that is again indicating that there is no problem of multicollinearity in the sense that all the variables x1, x2, x3 and x6, they are independent. And the model summary is also indicating that the value of R square adjusted, they are pretty close to 99%, and the R square prediction is also close to 99%, because the model is really good. But before I go further, let me try to point out one thing. Usually in experimental sciences, many scientists and researchers, they believe the outcome to be good only when R square is pretty high, say more than 95%. But if you are really considering a real life data, the possibilities of getting such a high values are not really very high, because the interpretation goes like this, that when I say that the model is 99% good, that means it is really close to the true experimental setup. Well, if you get it, that is very nice, but in real data surveys, it is difficult to get such a high value. So, but that is the choice of the experimenter to decide whether he considers the R square equal to 0.7 to be higher value or a lower value, or even a R square equal to 0.9 to be a higher value or a lower value. So, when we are doing a regression analysis, it requires some theoretical knowledge, understanding of basic fundamentals, understanding of the experimental conditions, and the condition under which the data has been collected, the role of those variables in experimental conditions, environment in which the data has been collected, and finally this is the only experimenter who takes the final call. Okay. So next we have obtained here the analysis of variance table, and so now in this case our H naught is going to be H naught beta 1 equal to beta 2 equal to beta 3 equal to beta 6 is equal to 0. And one can see here that this p value is coming out to be close to 0, and all other values are also smaller than 0.05. So one can see here that the H naught is rejected, and all the variables x1, x2, x3 and x6, they are contributing towards the model in explaining the variation in the value of y. And here we have obtained the fits and diagnostic for the unusual observation, and we had seen earlier also that these many observations have been diagnosed to be either having a large residual or an unusual observation. But here you can see there is a change, that now here there are two observations which are indicating that they are unusual. Earlier there was only one observation which is unusual. Well, these things are going to happen, and that is why we need to revise our statistical analysis again and again till we reach to a good model. So I am not going into the details of this outcome, but the suggestion would be that we try to delete these observations from the data set, and we try to conduct the entire analysis once again. In fact, a good suggestion is that after the first regression analysis, for example, we had obtained that these many observations were these many observations have some trouble. So a better option is to just conduct the entire analysis once again without deleting x4 and x5, and then we try to see the outcome, and accordingly we have to take a suitable decision. Well, Now here based on the value of HII, deleted residual, standardized residuals, you can also take a conclusion and you can decide that which of the observations are going to be influential, outlier, or say anything else, right? So now we have plotted different types of graphical diagnostic, and here also you can see, as earlier, there is no issue of here normality assumption, but here, for the sake of understanding, I have plotted only here one histogram of only the standardized residual, and similarly we have obtained the diagnostic or a graphical representation of residuals versus fits, but we have considered only here the ordinary residuals, and we can see here that all these points are nearly enclosed inside a horizontal band. So the assumptions like constant variance and other things, they are satisfied here, and we have obtained the normal probability plot here for the ordinary residuals, and we have obtained that that most of the points are lying near the straight line. So this gives us a sort of assurance that the observations are coming from a normal population. So now from this example, you can see that whenever we are trying to do a statistical analysis and we are trying to find out a linear regression model, the story does not always go in the nice way. There can be different types of problems. And our objective is that we try to start the linear regression analysis using all the possible variables, and we try to observe from the statistical output that what can be different reasons, or what are the different types of basic fundamentals which are indicating that the linear regression analysis outcome has some problems. Based on that, once we have a clear understanding of the basic concepts, we can diagnose more clearly and more specifically about the presence of a particular type of problem in the data set. And then we have to accordingly move forward. One thing I would like to inform all of you that in this course we have considered only the multiple linear regression model under some types of standard assumption. Once these assumptions are not fulfilled, we have developed the diagnostics, but we have not discussed what are the different solutions. Right. So that part we have not covered, but I am sure that in case if you first try to understand these basic fundamentals, possibly in the next course or in the or even yourself, you can study from the books and can really understand that if you are facing a particular type of problem like as heteroscedasticity or say autocorrelation, or the independent variables are not independent, that is the problem of multicollinearity, how to obtain a good solution. So the objective of this example was to show you that the linear regression model is not usually obtained in a single step, and we have to revise the model again and again till we get a good model. And usually it happens that if we are trying to do it honestly, finally we have a good model. So we will see you in the next lecture, and till then, goodbye.